Hey guys, Mr. Enyard here. Today we're going to talk about Lesson 12 in Module 2 of Engage New York or Eureka Math in 6th grade. We're going to talk about rounding and estimating and how that helps us to know where to start as well as to check our answer for reasonableness. And then we're going to talk about how we break down a division problem using multiple digits, so dividing by two-digit numbers, and how estimating and rounding can make it a lot easier for us to work through those problems. So make sure you know your math facts, multiplication, 0 through 10, and come with a good work ethic. We'll be ready to rock. Let's do it! Okay guys, so today we're going to be in Lesson 12, as I said earlier, estimating digits in a quotient. So if we have a question like this, 150 divided by 3, pause the video right now and explain out loud how you would solve this in your head. So most people say that they would cross out the zeros and they would have 15 divided by 3 and they would get 5, and that's absolutely correct. And the reason that works is because this is 15 tens, and this is 3 tens. And when you divide like units, you can cancel those units out, and therefore you just get a 5 left over. 15 divided by 3 is 5. Well, what if my original problem was 157 divided by 31? Now pause and ask yourself, why did I round the numbers to 150 divided by 30? Why not 160 divided by 30? Because technically 157 is closer to 160. All right, so I hope you guys kind of realize that the reason we used 150 and 30 is because 15 and 3 is an easy mental fact. It's part of our math facts that we learn from 0 to 10. You know, 3 times 5 is 15. 15 divided by 3 is 5. Fact families. And so if I round it to 160, 16 and 3 don't go together. So I let my math facts, my multiplication math facts, guide my estimating and rounding. And then I want to get it down to the simplest fact possible. Okay? Simplest fact possible. And so this is actually what the rounding would have been if this was my question. So let's look at number 1 real quick. We've got 2,970 divided by 11. And you're going to see this a lot. It says round to a one-digit arithmetic fact. And I'll explain that here in just a second. But let's start by doing what we would expect to do here. The first thing you'd want to do is, as most of you know, you would round the 11 to a 10. And this already ends in a 0, so theoretically you could just leave it alone. And we know dividing by 10 means we're just going to be losing a place value, so my answer should be close to 297. But to get to a one-digit fact, I don't have that. Okay? What I would have to do is I'd have to round to the greatest place value or second greatest place value to get to a basic fact. So I'm going to change this to 3,000 divided by 10. Now I've changed this number twice now. I changed this, I left it at a 10, but now I've also changed my big number, which means this answer will probably be a little farther off of the real answer because I've added more change. And what do I really get to here? Well, I really get to 3 divided by 1, don't I? So my one-digit division sentence is 3 divided by 1 equals 3. But since I've got 110 and I've got 300 tens, my answer would be 300. So now at this point, I calculate the real answer, and you can go ahead and do that if you want. But my real answer is 270. And as you look, yes, it's closer to this one that only changed once. It's farther from this one that changed twice, but both of these are still really close to this. So rounding helps me check that, my answer is reasonable, but it's also going to help me divide by 11s. I can just think of how many 10s I would use, and then I can compare that to how many 11s. So let's check out number 2. Why don't you pause the video and see if you can follow the directions and solve this one, then check back with me. So a lot of you probably looked right here at the 12 and said, well, that's pretty close to 10, so we're just going to do divided by 10. And then if you did leave it at 4,750, you only change this digit, then you know your answer has to be close to 475. However, that doesn't get us the one-digit 1 at once, so we're going to round it to 5,000 divided by 10, which is going to give us 500. So again, if I had 500 tens divided by 110, I have 500. So now you calculate the real answer. And as you see, the real answer was 396. Now, some people looked and said, whoa, dude, that's more than 100 off. Well, it's more than 100 off of this one, where we changed both numbers. So there's a lot of change going here. We're changing our sets that we're dividing it into twice, right? And we're changing our original number here by, almost 250. Up here, we only changed it by 2. But we still changed our groups by 2, which is really changing the number a lot. So yeah, we're going to be a little more off of our answer. The more change we make to the original numbers when we round, the more off our answers will be. But they're both 3 digits, right? And they are, this one's within 100, this one's a little over 100, 104, but they're still close enough to say that this is reasonable. Okay, so now we're getting a little bigger. We got 5 digits divided by 2 digits. And we're going to round this. And again, let your multiplication facts guide you. What would you do? All right, very good. I'm going to round this to 12,000. And I'm going to round this to 20. Why? Well, 12 divided by 2 is 6. And since it's 1,200 tens divided by 2 tens, that means my answer will be 600. So my basic fact is 12 divided by 2 equals 6. So go ahead and calculate the answer. See how well you did. Okay, so the original answer is 613. Whoa! Look how close that is. That's only 13 off. We're definitely reasonable with this. Now let's see how much we changed this. Well, this is a bigger number than 11 and 12 were in the previous problems, and we only changed it by 1. Now this number we changed by 353, but it's a 5-digit number, so that amount out of a 5-digit number isn't as big as a proportion to that number as it would be if it was a 4-digit number. Okay, let's do one more together real quick, and then I'll give you 3 problems to do on your own. Pause the video, and then check back with me. Okay, so again, what we have here is a 5-digit number divided by a 2-digit number, and we want to find the easiest way to do this mentally. And so we'll start 18 is going to become 20. So we're looking for an even number here. And 40,000, do we want to change that to 41,000 and make that even harder for us? No, we're going to leave it at 40,000. And so my basic fact here is 4 divided by 2 equals 2. And since this is 2 tens divided by 4,000 tens, my answer is going to be 2,000. So now calculate it. Actual retail price. I'm just kidding. The real number was 2,258. Now look, that's only 258 off. That's pretty close to 2,000. In fact, this would round to 2,000. And I went down on this one, but I went up on this one. So the amounts that I'm changing, the direction that I'm changing affects how close or far away I am from the final answer. Okay, so this section is going to go kind of quick, but I want you to pause the video, try these problems out, write your answers down as to what you would round them to be as close as possible, but also use the simplest facts possible. And then calculate the answers using a calculator. and compare your answers. Go ahead and do that now. Okay, so here you have your answers. So the red will be the rounded answer. And then here on 5, I added a green one because I noticed a connection on how close this was to a multiple of 15. So let's look at 4. You can see I've put a little straight face here because it's, this is a pretty long ways off. When I round this, it's pretty close to 1,200. However, 14 groups is 4 away from 10. That's a pretty big gap. I mean, when we've got 4, 5, and 6 here, we're changing the groups so much that we're going to change our answer a lot. So you guys are noticing the more our divisor changes, the farther from our answer we're going to be. But for 5, yeah, I could round this to 10, which is easier. I could round it up to 20, which I could do. The problem is I'm already rounding this up over 1,000. If I round this up to 20, I'm going to change this. This is going to be something even more astronomically huge, which isn't going to be anywhere near this. However, I can leave 15 alone because I notice 48 is only a few thousand away from 45. And 45 is a multiple of 15. 15 times 3 is 45. So knowing that, that allows me to get a little bit closer to my real answer. As you can see, I'm only 255 away here, and I'm 1,645 away here. That's a lot, right? But this kept me close because I didn't change my divisor at all. I was able to find an easy fact multiple of it. And that only works, obviously, when you're dealing with numbers you know well. And I just know my 15s because of time. 15 is quarter hours, right? So 3 quarters would be 45. And that's how I know that 3 times 15 is 45. And then lastly, on number 6, final answer, this one was only about 1,400 away, 1,456 away. So we would round this to 140,000. This would just round up to 20. And 14 divided by 2 is 7. And then we put our zeros on after we cancel off the 1. And we get 7,000. So there you go. So that's it. Hope that helps. Lesson 12, Grade 6, Module 2, Eureka Math, Engage New York. The more we change the problem and when we round and estimate, the more we will be off when we get to the answer. But it's still going to be close enough to say, yes, that's reasonable, or to give us a good starting point when we divide larger numbers. So hope that helped, and I hope to see you tomorrow. Have a good day.